this next scenario, which was solving exponential and logarithmic equations, and it's where I'm using the properties of logarithms to rewrite the problems. In a couple of the previous scenarios, I have shown examples where you do utilize some of those properties, but this is a specific one where you really want to use it. I cannot solve an equation when I have multiple logs. So when I have multiple logs in an equation, I want to be able to condense it first. So remember, the log property addition just turns into multiplication. So I can say this is log 2x times x minus 5 equals 2. And now that I only have one log left in my problem, I can take the inverse of it. So this log has a base of 10, so I'm going to raise that as an exponent, 10 to that power. So log 10 to the log of 10 cancels out, so I'm left with 2x times x minus 5. And then here I have 10 squared, which turns to 100. So now I'm going to distribute 2x squared minus 10x equals 100. And I'm going to do 2x squared minus 10x minus 100 equals 0. I'm going to take out a PCR. And I'm going to factor. So I have x minus 10 and x plus 5. So x equals 10 and negative 5. Now I'm going to plug them in and make sure that none of my outcomes of my logs are negative. Log of 10, that works. Log of negative 5, that doesn't work. Logs are not allowed to be negatives because on my parent function of the log, it looks like this, and your x values are always positive. I'm going to skip number 13. I'm going to go down and look at number 14. Number 14, because I have two logs on one side, I have to be able to condense it before I can get rid of it. So how I'm going to condense it, subtraction just means division. So I'm going to say log base 2 of negative x plus 2 all over x minus 2 equals 3. So now, because I only have one log, I can get rid of it by doing the inverse, where I take it and create an exponent. So 2 to the power of log 2 cancels out, so it's negative x plus 2 over x minus 2. And 2 to the third power equals 8. So now I'm just going to solve. I'm going to multiply both sides by x minus 2. So those cancel out. I'm left with negative x plus 2 equals 8x minus 16 if I just distribute in my head. So now I have 9x equals 18, so x equals 2. And if I plug that in, I get log of 0. When x is 2, I get log of 0. So you're not allowed to have log of 0. And even if you were to go into Desmos, if I open up Desmos real quick and show you, and I were to come down here so we can see it, if I were to type in log of 0, it's undefined because log can't be 0. You're right. So this would be no solution. Okay? So this is how I would solve a logarithmic equation using those logarithmic properties.